Welcome back to the deep dive. Today we're zooming way in on one tiny but super important piece of hardware. We're talking about the Thor Broadcast F-RF-RX-MN-2.
Yep, the mini fiber optical receiver.
And this is really the unsung hero at the end of the line, right? It's the thing that actually gets that blazing fast fiber optic signal into a language your TV can understand.
It is. I mean, think of it as a highly specialized interpreter. That's really the best analogy. It's built for fiber to the home, the FTTH network.
Okay.
You've got pure light zipping down a glass cable, and this little box just instantly translates it into a standard electrical RF signal. Specifically, 45 to 1,000 megahertz, which is what your cable box is looking for.
And it's also TAA compliant, which I thought was interesting. So right out of the gate, it's cleared for things like government contracts. That says a lot about its reliability.
It really does. So if we break down what it's doing, that technical bridge it creates, it has to be incredibly flexible.
Right, because it's not just one signal type.
Not at all. It handles everything from old school analog NTSC and PL formats all the way up to, the modern digital QAM, ATSC, DVB-T. Doesn't care what the format is.
So how does it handle the actual light signal? Because on these networks, you often have multiple signals on different wavelengths, don't you?
You do, and that's where the really precise engineering comes into play. This receiver is built to listen on a very specific wavelength, 1,550 nanometers.
Okay.
But the secret sauce is a built-in filter. It is designed specifically to ignore the 1490 nanometer signal, which is often used for other data.
So it's like putting on noise-canceling headphones. It only listens for the one voice it needs to hear.
Exactly. And that's what helps it maintain, really excellent linearity and a flatness of plus or minus 1 dB. It keeps the signal incredibly clean.
That internal stuff is key, but I feel like the biggest problems always come from the physical connection itself. What's the one thing you absolutely have to get right when installing this?
It is all about the connector. You must, and I mean, this is non-negotiable, you must use an SKPC connector.
An angle-polished connector.
Yes, an angle-polished connector.
So why is that angle so important? What happens if you just plug in a standard flat one?
You get light reflection. It's the mortal enemy of fiber optics. That reflection bounces signal energy right back up the line, and it degrades the incoming signal immediately. You'll see video dropouts, poor quality, all of it.
So if your building has older flat connectors, what do?
You have to use an optical jumper,
Yeah.
a small cable that converts that flat PC-type connector to the SKA-PC you need. It's an essential extra step.
Got it. So protect the signal integrity at all costs. Once it's converted, the output is pretty simple, though.
Oh yeah, super simple. It gives you that RF signal through two standard coaxial ports, the F-type female connectors that everyone's familiar with.
Yeah.
Makes it really easy to split it to a couple of TVs.
And even though it's a tiny box, it does give you some basic diagnostics with the LEDs, right?
It does. You get two lights.
Okay.
One is just a red LED for power, pretty standard. But the other one is the alarm LED.
Right.
And that's your quick health check. If it's green, you're good. Your optical power is in the right range, roughly -6 to 0 dBm.
And if it's red?
If it's red, you have a problem. Your signal is too low, it's dropped below -8 dBm, or it's gone completely. It's your first stop for troubleshooting.
And wrapping up with the commercial side, it's listed at $495. It's got a 2-year warranty, free shipping in the US. And it's usually sold as a kit, right?
That's right, often with its counterpart, the F-RF-RX-MN-2 LW mini transmitter, the device that sends the signal in the first place.
So really what this all means is that this tiny device is the critical link that makes the huge investment in fiber actually pay off right there in your living room.
It flawlessly translates that light back into a signal, no matter the format.
And I guess the final thought here, the thing to really chew on, is the incredible amount of precision packed into such a small, simple-looking component. Think about what it takes to get a perfect high-level output like 70 or 80 dB microvolts while fighting against something as subtle as light reflecting off a connector that isn't angled just right. It really shows you how much engineering underpins our daily digital lives.